This video is for The Living Earth, Unit 2.6, Erosion and Deposition. Today's essential question is, how can engineering design solve problems caused by erosion? Our first main idea, beach erosion. Many erosional problems are caused or exacerbated by human activities. Coastlines are eroded continually as seawater ebbs and flows and waves crash upon the shore. These are natural forces, but humans also contribute to erosion. For example, as people build homes, roads, and other structures along beaches, they alter the natural topography. Construction often eliminates protective sand dunes and weakens bluffs, exposing even more of the beach to erosion. Eroded shorelines may be especially vulnerable to hurricanes or other types of storms. As sediments are washed away from the shoreline and it changes, human-made structures may be damaged or even destroyed. Engineers have developed a number of strategies to protect coastlines and coastal structures from erosion. Different strategies have different advantages and also disadvantages. Some strategies actually may have caused more erosion than they prevent. For example, shoreline hardening involves building seawalls and other hard structures along a coast. These methods are primarily intended to protect property from waves. Unfortunately, the hard structures reflect wave energy to other parts of the coast that may be less protected and thus more vulnerable to erosion. Sand retention structures, such as groins, stick out from the shore. As flowing water carries sediments along the coastline, the sediments are trapped along the retention structure. This can prevent erosion on one side of the structure, but it can exacerbate erosion on the other side because sediments that normally would be carried to other parts of the beach are prevented from moving there. Beach nourishment is a process of replacing eroded sand with new sand from other locations, including inlets, healthier beaches, and offshore sources. The new sand is added to the eroded beach or used to shore up the continental shelf or dunes farther inland. When properly designed, a nourished beach may incorporate a variety of natural and man-made structures that help reduce further erosion. Disadvantages of beach nourishment include high cost. Furthermore, because nourishment does not stop erosion from happening, the beach typically must be replenished with new sand every few years. Soft stabilization involves adding plants and other organic substances to an eroded shoreline. These soft materials can trap sediments while preserving the natural features of the shoreline. They also can create new habitats for organisms, thereby contributing to the ecosystem's biodiversity. Unfortunately, soft stabilization may not always be a practical solution, especially in environments with high energy waves. Erosion is a natural process that never can be stopped completely. Limiting construction along coastlines can slow the rate of erosion, but the best way to avoid coastal erosion problems is to avoid building along the coast in the first place. As this is rarely a realistic option, engineers continue to look for better ways to protect coastal structures from erosion that happens when wind and water meet land. Our next main idea, river erosion, Niagara Falls. Humans do not cause every problem related to erosion. Flowing water, blowing wind, and other agents of erosion continually are reshaping Earth's surface, regardless of human activities. Consider the spectacular waterfalls at Niagara Falls, which provide enough hydroelectric power to generate 1/4 of the electricity used in the state of New York and the Canadian province of Ontario. Niagara Falls also attracts millions of tourists each year, Yet each year, the tourists find the waterfalls a little bit further upstream. Thousands of cubic meters of water rush over the falls every second, slowly eroding the surrounding rock. Scientists estimate that for centuries the falls recede 1 meter or more each year. Now, to slow this rate of erosion, engineers have built underground tunnels that carry large amounts of water away from the falls. Much of this water is redirected to the hydroelectric plants and used to generate electricity. Where possible, engineers also have reinforced the rocks underneath the falls. As a result of these efforts, Niagara Falls now recedes approximately 1 foot per year. At that rate, the waterfalls may disappear completely in 50,000 years, though a rapidly flowing river will remain. Scientists think that the rate of erosion may be reducible to 1 foot per decade. Even so, we probably cannot keep the falls from someday eroding away completely. At this point, you should be able to generate a full and appropriate response to today's essential question: how can engineering design solve problems caused by erosion?